Welcome to Day 2, Arithmetic and Geometric Sequences. We're going to look at sequences that we did last class, but these sequences will have a special pattern. So let's look at special patterns. The very first one right here, I see that I'm adding 3 to every term. And this one right here, I am subtracting 6, but it's actually better to say add -6, and we'll talk why we should do it that way in a minute. So we have an arithmetic sequence is an adding pattern. Yes, I said that word correctly. When it's a noun, it's arithmetic. When it's an adjective in front of the word sequence, it is arithmetic. It is an adding pattern. It means you're always adding the same thing to every term over and over and over again. And that is called a common difference. And we're going to use the letter D for the common difference. And the idea is what we're doing. We are repeating addition. We keep on adding the same. It's repetition of addition. It is a linear pattern. So I'm going to use the letter A for arithmetic sequence. And the two things I need to know are a sub 1, the first term, and the pattern or the common difference, the D value. And here is my formula right here. Using an explicit formula. Remember, that is just one equation. The two things I know are the first term and the difference. And n is my variable. That's what I'm going to change. First term I use n equals 1. Fifth term I use n equals 5. And over here, I have my recursive, which is again more than one equation. In this case, it's going to be 2 equations. I need a starting point, and I need a pattern. And that's what the second equation does. It is a pattern. And the things that are given, things I need to know, are again the first term and the difference. But this whole thing right here, a sub n minus 1, that is the variable. So I'm going to write their explicit and recursive formula using the formulas I have above. And the two things I need to know are the first term, so t sub 1 is equal to 5. And the difference here, I see that my difference is -6. I'm subtracting 6, but I'm going to use -6 for addition. So I did the explicit. I plugged them into my formula. I plugged the first term of 5 and the difference of -6 in here. I'm going to do some distribution here. I get 5 minus 6n plus 6. And then I'm going to clean it up. And I get t sub n is equal to -6n plus 11. And I look at this. And I'll make, wow, that is a linear equation, which I said it would look like. And I have a slope equal to -6, and that just happens to be the D value. That's not by coincidence, that is by design. For the recursive formula, I do need the first term. Well, the first term is 5. And the pattern is subtracting 6, so I do t sub n equals, and this is the hard part, the notation, t sub n minus 1 minus 6. You don't have to put the curly brackets around it. I like to. And I'm going to box it. And that is the pattern that we're looking for. This says my first term is equal to 5, and every new term is equal to the last term, my last result, previous term, minus 6. The next one, I see that my first term is equal to 2, and my difference is, well, 7/3 minus 2 is 7/3 minus 6/3. My difference is 1/3. Okay, with those first term and D value, I could plug it into the explicit formula. I do a little distribution. 1/3 minus 1/3 n minus 1/3. And I clean it all up. I get a sub n is equal to 1/3 n plus 5/3. And the recursive one, it's pretty easy to write. The first term is given, it's 2, and the pattern is adding a third. So a sub n is equal to a sub n minus 1, the last answer, plus a third. And there we go. Those are the way we write those formulas. So how do I write the formula if I don't know the first term, if I don't know, and the difference is not as apparent? Well, first of all, I have to know it's arithmetic. And I know the third term and I know the sixth term. So I'm going to fill in some blanks. Blank, 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 blank. Here is the third term. Here is the sixth term. And those values I know. The third term is 8. The sixth term is -1. I don't know the first term, but I do know that between terms I'm going to go add D, add D, add D. And I can write the equation 8D, excuse me, that's bad, my bad, let me see if I can erase. Okay, try again. 8 plus 3D is equal to -1. That's what that says up there. Subtract the 8, and I get D equals -3, and I have my D value. And now I can go back, I could fill in to find the first term. Well, if I'm going backwards, then this has to be 11 and this has to be 14 because I have to subtract 3. So I know that my first term is equal to 14. My D is -3, and now I can write my formula. I went ahead and finished this problem, and using my my first term of 14, my D of -3. I do want you to clean up the explicit to make it look like a linear function. So let's look at these next 3 to see if they are arithmetic, because they have a common difference. That means you have to be adding the same every single time. Well, this goes by 5, by 4, by 3, so this is not arithmetic. This one goes up by 5, by 5, by 5, so yes, it is. And the D value is equal to 5, and this one goes down by 7, down by 7, down by 7. So yes, it is, and the D value is equal to -7. So again, let's look for patterns. So for this one, I do see a pattern of multiply by 2. We've seen this pattern before. And this one over here, I look at this, and I'm thinking, one way to say it is divide by 4, but we're going to do something different today. I think better for us is saying multiply by 1/4. That's really a better way of saying it. So I'm going to be looking at geometric sequence. It is a multiplying pattern. Arithmetic begins with an A. It's adding, multiplying. It's geometric. It's got an M right there in the middle. It is a sequence with a common ratio, or what we call a multiplier between consecutive terms. And that R value is what we're going to use for that common ratio or that multiplier. It is important to figure out what the multiplier is, not if it's dividing, what it's multiplying by. If you're not sure of what the R is, you always could do a second term divided by the first term to see if you get the R value. Or you could do third divided by second, or fourth divided by third, etc., etc. But those are the things that we need. What we really need, we need to know the first term, and we need to know the R value, the common ratio, and the multiplier. It is important to know those two things. Let's see if I can get this time. Okay, that's what we need to know. Arithmetic, we need to know the first term and the difference of what we're adding. This time we need to know the first term and the common ratio. And here are the formulas. First formula, again, is right here, the explicit. It is one equation. The two things I need, the first term and the R value are right here, And the n value right here is the variable. And over here, again, the recursive is always more than one equation. It is my starting point and some pattern. And this time, remember, the subscript n-1, that is always the variable. Let's write some formulas using what we have above. Well, this one's easy. The first term is equal to 3, and my ratio is equal to 2. It's very easy to see that. So let's write our formulas. Okay, I'm going to do my explicit and my recursive. My explicit is going to be the one equation, g sub n is equal to first term, parentheses, 2, raised to the n minus 1. And there's my formula for that. And my recursive has got to be two things. My first term is equal to 3, and g sub n is going to be the pattern of 2 times g sub n minus 1. That's my variable. That's my curly brackets, and there's my box. Okay, again, it's very easy to see that the first term is 27, and my r maybe is a little bit harder to see. So I'm going to do the second term divided by the first term, which is negative 1/3. Now, same thing if I did the third term divided by the second term, I still get negative 1/3. So my r value is negative 1/3, so now I can write my formulas. Now, b sub n is equal to the first term, parentheses, the r value of negative 1/3, raised to the n minus 1. That's all you need. And over here I need two equations. My first term is 27. My pattern, b sub n is equal to negative 1/3 times the previous term, b sub n minus 1, curly brackets, and if I want to box it, I can box it. So again, how do we write something if we do not know first term? Well, I do know it's geometric, and I do know the second term, and I do know the sixth term. So I'm going to draw some dashes, first term, second term, third term, fourth term, fifth term, sixth term, and I know those numbers. That is 8, that is 1/2. Now with arithmetic, we are adding these all the time. For geometric, we are multiplying by r's. We're not adding, we're multiplying. So I get a nice equation that says 8 times r to the fourth is equal to 1/2. I'm going to divide by 8, or multiply by 1/8. I get r to the fourth is equal to 1/16. I'm going to take the fourth root, and I get r is equal to 1/2. And now, I could fill in for the first term. Well, if I'm going by half to the right, I have to have 16 here up front to get 8 as a second term. So now I know my first term is equal to 16, and my r value is equal to 1/2. So now I can write my formulas. So you can see I just plugged them into the formulas from previous up on the page. Pretty easy to write these formulas for explicit and recursive, just plugging in the first term and the r value. So let's see if they're geometric, based if they have a common ratio or not. Well, this first one goes times 3 times 3 times 3 times 3, so yes it is. My r value is equal to 3. The second one goes times 2 times 2. Ooh, not times 2. No, it's not. And this last one, let's see, from 2 to here, it's times negative 1/2, times negative 1/2, times negative 1/2, so yes it is. And r is equal to negative 1/2. Okay, thanks for watching the video.